We're looking at number 11. Number 11 says G is a circumcenter. That means it's the center of perpendicular bisectors. As a result, we have AD is equal to DC. We have, what else? We have CF is equal to BF. Then lastly, we have EB is equal to AE. 1, 2, 3. And on top of that, we have a right angle. So I didn't do that last time, but we do know that. And lastly, from the vertice to the circumcenter, they're equal. AG is equal to GC, which is equal to GB. And what we have here, we're trying to find GF. So I have a hunch we're going to have to use the Pythagorean theorem again. That's what I think we're going to have to do. So when we look at this, we have the following information. We have AG is 6x plus 1, so this is 6x plus 1. GC is going to be 9x minus 11, so 9x minus 11. And then finally we have BC, the entire length is 38. If that's the entire length, then half of 38 would give us the following. I think it's going to be 38 divided by 2, 19. So it's 19. And I want to just emphasize this GF right here. We want to find this GF right here, this length. So my hunch is we're going to have to use the Pythagorean theorem. But let's just start with what we know. First, we have GC is equal to GA. They're equal to each other, so we need to find the value of x because we can't even use the Pythagorean theorem if we don't know GB. So first, what we're going to do is we're going to say AG is equal to GC, and then we're going to plug in the values. We have 6x plus 1 is equal to 9x minus 11. From here, I'm going to subtract 6x, get 1 is equal to 3x minus 11, add 11, you get 12 is equal to 3x, and you get x is equal to 4. So that means from the vertices to the circumcenter, x equals 4. So from here, let's just figure out what one of them is going to be. So if AG is equal to 6x plus 1, that's really going to give us 6 times 4 plus 1. 6 times 4 would give us 6, 12, 18, 24. 24 plus 1 give us 25. So that means the length of all the centroids, or not centroids, circumcenter to the vertice is 25. So this has to be 25, this is 25, that's 25. So from here, we're going to have to figure out what we need to do. Well, it's definitely going to be a Pythagorean theorem problem. The reason why I know that is we're looking for GF when we are given 19 and 25. So let's do that. Nice. So from here, we have the Pythagorean theorem, which would state this is our right angle. So that's our largest side, and we're trying to find GF. So we have 25 squared is equal to GF squared plus FB squared. FB is actually 19. I'll fix that in a second. So we have 25 squared minus FB. I'm going to subtract it. FB minus FB squared, which would be 19. So 25 squared minus 19 squared equals GF squared. From here, you can just use your calculator to do all the heavy lifting. So 25 squared minus 19 squared would give you 264. is equal to GF squared. And then, as we can recall, the inverse of an exponent is a square root. So from here, square root both sides, and you get about 16.2. So the length of GF is about 16.2.